Hey there, ladies and gentlemen, and welcome to the continuation of 8.5. All right, so we're just talking about one real big idea here. I didn't want to talk about it with the first part because it might get things a little bit confusing. So today's talk is basically about factor by grouping, but we're going to start with a little quick review. Remember that factoring is us just taking the greatest common factor of all items and removing it. We're undoing the distributive property. So if we look at a 15x and a 25x to the second, the largest number we can take out of both of them, which means to divide out, would be a 5 and an x. So when we take 15x and divide it by 5x, and when we take 25 and 25x squared and divide it by 5x, we're left over with items. So the leftover items are what gets left on the inside here. So when we divide out the 5x, we're left over with 3. And when we divide out a 5x from this 25x to second, we're left with a 5x. And so if we were to distribute, we'd see that this was back to what this problem was. So we're undoing the distributive property. So on example B, the largest number we can take out of all three of these is a 6, because 12, 24, and a 30. We can take out a 6. And then the largest number of x's we can take out would be an x, just x to the first. Largest number of y's we can divide out of all three would be a y to the first. And so the stuff that we're left over, again, basically we are dividing by this GCF of a 6xy and writing down what is left over. So we have a 2 for the starting of our first term. 24x y to the second divided by 6xy gets us to a plus 4y. And then the third piece here, the third term, a negative 30 divided by 6 gets us a, not a plus, I don't know why I wrote that, but a minus, a negative 5. And then x to the second divided by x gets us an x. Y to the fourth divided by y gets us a y to the third. So we're reusing our skills from Unit 7, and this would be what is left over using the distributive property. Now the thing that we really want to talk about is factoring by grouping. What happens is we will use this strategy when we have 4 or more terms. So we're going to group together using the associative property, the commutative property, to group things together and then be able to come up with taking a common term out. So if we look at these numbers, you can see that it'd be really nice if the 7x and the 7 went together, and it'd be really nice if the 2xy and the negative 2. So if I rewrite this, I'd have a 2xy minus 2y. So those are my two chunks I'm going to group together, and then my plus 7x minus 7. So that's my other chunk that I'm going to group together. Now we're not multiplying these things together, I'm just putting them in parentheses to show that they're grouped together. So what we're doing now is we're going to divide out a common term from my first grouping, divide out a common term from my second grouping. So I can divide out of here a 2 and a y, and what's left over would then be a x and a minus 1. Now on this one, when I divide out, I'm looking to divide out a 7. And when I divide out a 7, it's going to be a positive 7, so I put plus 7. I'm left over with an x and a minus 1. Now exactly what we wanted to have happen, happened. Fancy that. But we wanted our leftover stuff to be the same. So now here's the really cool part. What we can do is, because 2y and 7 are both multiplying to the same thing, we can make two groups from this. One of them is the group that was already written there, the x minus 7, but the other one comes from this 2y and this plus 7. So I have a 2y plus 7 and an x minus y. And that is my factored out answer. So that's what we're looking to have happen, is us to be able to create stuff like that. All right, let's try one more. And see what we can do. So I'm going to group together these first two, and then I'm going to group together the second two. So when I take out of a 15a and a minus 3a, I can divide out a 3a, and I will be left with a 5 and a minus b. On the other one, I can divide out a 4. And when I divide out a positive 4, I'll be left with I'm going to call this a negative 4 so it works the way we want it to work. We're going to divide out a negative 4 so that we are left over with a negative b and a positive 5. So that's why I'm choosing a negative 4, so I'm left over with a b that's negative and a positive 5. And that's the confusing part about this one. So these two things could get switched around, or I can move these two around so it says the exact same thing as the other one. And we're trying to make them be the same thing on the inside. So I'd be left with a 5 and a negative b. And that makes us have our two situations that are two of the same thing. So I'm left over with a 3a minus 4 for one of my chunks, and the other chunk would be a 5 minus b. So if I were to FOIL these things, I'd end up with this as my answer. All right, folks, that's all I have for you. We'll be using these kind of things along with the zero product property and what we talked about from the first part of 8.5. But that's what I want to talk about. Oh, and the bell rang. Uh-oh, this is the Burma Nation. There's kids coming. I'm signing off. Get out of here.